We had previously talked about this idea of outliers, which are really high or really low values that don't quite fit into the data. And now we're going to give an actual clear definition of what we mean by too high or too low. We're going to start with what's called the interquartile range. The interquartile range is defined as Q3 minus Q1. And this is going to be helpful for actually finding our outliers. So outliers are going to be numbers that are smaller than Q1 minus 1.5 times this interquartile range, or larger than Q3 plus 1.5 times this interquartile range. So 1.5 IQR tells us how high or how low we can go above and below our quartiles. And anything outside of this range would be considered an outlier. So let's do some examples to check for outliers. Here's our first example that we looked at. We already have all of our quartiles, so now we just need to test for outliers. And we're going to start by looking for too low outliers. For that, we need to look at Q1 minus 1.5 times IQR. So let's stick in what we know. Q1 is 68 minus 1.5 times IQR, and the IQR is Q3 minus Q1, so 91 minus 68. And once we work that out, we get 33.5. So to be an outlier, I would need a data value that's smaller than 33.5, and I don't have anything like that. The smallest data value we have is 42. Now let's check the other side, outliers that are too large. For that, we need to look at Q3 plus 1.5 IQR. So Q1 is 91 plus 1.5 times the IQR, 91 minus 68. Which is 125.5. So to have an outlier that's too large, we would need a data value bigger than 125.5, which we don't have. So for this data set, there are no outliers. Now let's look at this data set. We need to start by actually finding our quartiles. We're going to start with the median. There are 9 data values, so if I look at this 12 that I just boxed in, we can see 4 to the left and 4 to the right. So that would be our median, 12. To get Q1, I would need to take the median of everything to the left of this box. There are 4 numbers, so it would be halfway between 7 and 8, or 7.5. For Q3, I would need to take the median of everything to the right of this box. Once again, there are 4 numbers, so the one in the middle would be halfway between 13 and 14, or 13.5. Now that we have our quartiles, we can look at actually finding our outliers. We start with Q1 minus 1.5 times IQR. We know Q1 is 7.5, and the IQR is 13.5 minus 7.5. Working this out gives us negative 1.5, and since our data set doesn't have any negative numbers, we know we don't have any lower end outliers. Next, we need to check Q3 plus 1.5 IQR. Q3 is 13.5, so I have 13.5 plus 1.5 times my interquartile range. And that equals 22.5. So we do have an outlier because we do have a data value bigger than 22.5. 23 is an outlier in this data set. The next thing we'll look at is boxplots, and boxplots are a visual graph of our 5-number summary. To build a boxplot, the first thing we want to do is draw a box between our values Q1 and Q3. We then draw a line in the box at Q2 at our median. We draw a line from our minimum value to our Q1. And finally, we draw a line from the maximum to Q3. So let's look at some examples. Here's an example we looked at earlier of test scores on a statistics test, and we went ahead and found the 5-number summary for this previously, so I went ahead and copied it down. To do our box plot, we start with a box between Q1 and Q3, so I need a box between 68 and 91. So 68 is about right here, and we'll go over to 91, about right here. We then need a bar at Q2 at the median, so I'll draw a bar at 80. And then we draw a line between the minimum, 42, in Q1. We also draw a line between the maximum, 97, and Q3. So here's my box plot. And just like the quartiles break things up into 25%, each piece of this graph is also 25%. There's 25% in the bar, 25% in the first box, 25% in the second box, and then 25% in the last bar. So since each piece is 25%, we can actually get a lot of information from this. On the right, we see this really short bar that has 25%. That means that data is very compact. I have a lot of data value with not that big of a range. Whereas on the left, when I see this really long bar, that means the data is more spread out. I have the same amount of data points in a wider range. Here's another example we looked at earlier. I wrote down the data values. Earlier we found Q1, Q2, and Q3, and we found that the outlier was 23. So I went ahead and wrote all that information down. And when we have an outlier in our data set, our box plot looks a little bit different. So let's do an example to see how it would differ. We start the same by drawing a box between Q1 and Q3. So I'll draw a box between 7.5 and 13.5 with a bar at Q2. We then go ahead and draw the line from the minimum to Q1. However, we actually denote outliers by little dots or X's, so I'm going to put an X at about 23. So instead, my line is not going to go to 23, but it's going to go out to 14. So outliers get denoted separately as little X's, and then either the minimum or the maximum, depending, will shift over accordingly.